Okay.
Okay.
So I am here with my coworker, Martin Robinson from Igalia, and we're going to talk about accessibility. We do a lot of accessibility related stuff at Igalia, and you've been doing some of that. So just to start us off, I think there's kind of a interesting challenge with accessibility because it is just like really foreign to a lot of us. In almost every way. Like how you think about how something should work is very shaped by like your own modalities and what you're used to using. And I also think that nobody kind of explains the big picture, like the architecture of how all of this works. We just talk about like a screen reader and we don't sort of talk about how it fits together. So I've seen a lot of confusion over the years that have to do with not understanding some of this. I've even had some of my own. So, can you maybe explain some of the basic like architecture of it?
Sure. Yeah, no problem. I think that the most important thing to remember is that there's always at the end of a pipeline of accessibility technology, there's always a user using a specific tool, and then the entire accessibility stack is made to deliver information from the application to that tool so that the user can use the application. And one of the most important parts of that stack of technologies is this concept of the accessibility tree, which is an internal in-memory representation of the application, which allows the accessibility tool to interact with the application and also to get information out from it. If people are familiar with for instance, a DOM tree, the accessibility tree can be thought of as something similar to that, but consuming the application interface. Is that sort of what you were going for there?
It is, yeah. And when you say application, you mean like any application, right?
Right.
Like
An application like a web browser or a word processor or even the desktop shell that you're using will have a place in the accessibility tree. Will provide its own accessibility tree for the accessibility technology to consume.
yeah, that's really interesting to me because this is what I mean. Like I think a lot of people, including myself at various times, I'm not really sure why. I think it's because in the web we talk about accessibility a lot, um, but I guess I have always had this very very strong correlation in my mind between something like a screen reader and a web browser, and never have pieced together how those two things would fit together, and thought about the rather obvious seeming fact in retrospect that you use those screen readers for all of your applications, like your native spreadsheets and your native email clients.
Yeah,
And
that's right. Yeah.
so how do those applications that aren't web browsers, how do they create that accessibility tree? Like,
It really
do
depends.
they program?
Yeah,
Do they
it really
program?
depends on the application. I think for the majority of applications, if you can imagine that they're written in a toolkit like GTK on Linux, for example, or I want to say Cocoa, but what I really mean to say is the modern macOS UI programming. Um,
Right.
uh, and then Win32 controls on Windows, they all sort of have their own way of exposing accessibility objects to screen readers and other accessibility technologies. Typically, this is handled automatically by the toolkit. So if you write your application in GTK and you're not using custom widgets, it should just by default be accessible. The problem, of course, is that a web page is a piece of interface, and it's unclear looking at any particular web page how that should be exposed to a screen reader or to a braille display or something like that.
Yeah, it seems pretty clear when you talk about like headings and paragraphs and things,
Mhm.
assuming that something is well formed and follows good
Right.
practices. But when we get to the interactive things, this is very similar to the thing that you just said. Like if you're not creating custom widgets,
Yeah,
right?
it's a similar idea. If your web page is just a document with headings and paragraphs, then it's going to be exposed really nicely to a screen reader. But once you start adding images or more complex interface elements, a lot of web pages have these sort of elements. Just imagine Google Docs, for example. It's an entire application inside of a web page. And how do you expose the idea of a menu or buttons, especially when they're not made with the typical HTML form controls to the screen reader? How do you provide that bit of contextual information?
I think that's a point that we try to stress in the web platform itself too, right? Like there are lots of interactive
Right.
widgets
Oh,
and
for
everything
sure.
that give you all that magic, right? The magic is a pro and a con because you don't have to worry about it, but because you don't have to worry about it, you're
Hmm.
also not aware of it. So it's easy to like miss that.
Right. Yeah. For example, the button element has a lot of built-in accessibility support. And if you, for instance, create your own button just from a div or from an image or text, then it may not be exposed in the same way to the accessibility technology as that original HTML form button. And that's the kind of thing that you would miss by creating your custom elements.
It seems so easy. Like, I mean, what is a button? I don't know.
Hmm.
It's like a thing
Right.
that you click, right? Like at some level, that's true, but there is a sort of a bunch of hard work in that's wrapped up in a button, and you get it all for free if you
Right.
just
Yeah.
use a button. Let me like recap what I think is a simplified understanding.
Hmm.
Your apps, either directly or through some windowing toolkit where somebody has done a whole lot of hard work to build it. It builds and maintains this OS level tree, sort of like a DOM tree, but for accessibility. And it's not in the browser, it's at the OS level. And then some other app like consumes that and interacts with that. It's almost like client server communication.
Yeah, that's correct. The Generally speaking, the way this works is that applications will expose the tree through interprocess communication to some sort of desktop-wide broker that has all of the trees of all the different applications, and then those can all be presented at once, perhaps through another set of interprocess communication to some sort of client application, a screen reader, a braille display, maybe an on-screen keyboard, and that application will be consuming the trees through IPC of all the applications of the desktop. A forest, right?
So, like you're saying, through IPC, does it go in both directions? So, like, can your accessibility app move the focus in this application or something?
For sure. That is another huge responsibility of the accessibility tree is to accept requests from accessibility technologies for, like you said, moving the focus. Another big one is activating. So if you have a link or a button and the user wants to activate
Hmm.
that button, then the accessibility technology sends a message to the application, which in this world is considered a server. The application is serving up the accessibility tree and taking requests from clients, which are the accessibility technologies.
So I feel like that kind of helps illuminate the some of the stuff that's hidden from you because you look at it and you say, "Well, what is a button? It's just a thing that you can click. Like, what's so special about it?" But it needs to create this accessibility tree and also like receive events, and so like sort of the
Right.
contract of these things is considerably more involved than you think. And if you don't meet some end of the contract, something won't work the same.
No, for sure. No, that's
Um,
exactly right.
all right. So you had mentioned screen readers. I think they're the one that like everybody talks about. Um, our colleague Joni and Igalia are maintainers of one of those, the Orca screen reader for Linux.
Mm-hmm.
That's awesome. We do a lot of that as an investment.
No, yeah.
We all together choose to take some of the money that we could put in our pockets, and we all contribute it back.
Mm-hmm.
And
Yeah,
think
that's right.
I think that's really awesome. I mean,
Right. Yeah. No, for sure. That's kind of part of our core philosophy, I think.
yeah, this is the first time I have had the opportunity to work directly with people who like work on the screen readers and like down in the ditches and like do all the actual work on making that work. And it never dawned on me. It was kind of surprising for me to learn that like screen readers don't actually speak.
No. You think that they would read the screen, but no, from the name, but no, they don't.
Right, yeah. That's do you want to like say something about like clear that up somehow?
Sure. Yeah, I think it's important to note that screen readers use speech subsystems to actually produce the actual audio of the spoken content. So on Linux, for example, Orca uses a software called Speech Dispatcher by default, although there are other speech backends, and then there are similar speech backends on other platforms. And essentially, Orca can just send the text that it wants to speak to these APIs, and they'll actually produce the audio output. So text to speech is a whole other set of software and libraries. The screen reader sits on top of that.
Yeah, that's another thing that's really fascinating to me. I know you think it's your browser speaking, but it's not your browser speaking, right? It's like the OS level thing that knows how to speak.
Yeah.
Okay, so there's this mystical accessibility tree at the operating system level, and we said it's kind of like the DOM, but like, what's in it? Like that maybe sounds like a strange question, but as I understand, a lot of the concepts in Aria were developed like based on these accessibility trees. And that's another thing. Like are they the same tree in every operating system or can they actually differ a little bit?
No, they differ. They differ. They're very similar, but different platforms have different expectations of what should be exposed into these desktop-wide trees. So there is some degree of difference. I would say the vast majority of the contents are quite similar. An example of what sort of thing is in the tree is for example, you look at it's just imagine a tree of nodes, and each node can have children and then certain properties on that node. One, probably the most important property of the node is the role. And the role basically gives some indication of what the purpose of that node is. For example, there might be a role label for labels, role button for buttons. In ATK, there's role panel for generic panel elements, and that kind of tells the screen reader what the purpose of that node is. Another thing that each node might contain are states. Is this item focused? Is it selected? And then also attributes. For example, you can imagine a DOM attribute, which include things like ID or style classes. The accessibility nodes also have attributes.
Yeah, that sounds a lot like Aria. My understanding is that Aria itself was sort of shaped based on these common concepts in different operating systems and sort of imagining how to provide a uniform way to express all this for the web platform with standard mappings to each one. Have I got that right?
I think that's correct. So at least in my head, Aria can be thought of as a platform independent version of platform accessibility tree, and then can later be mapped onto the real platform accessibility tree. There's actually a series of specs that kind of track this layering. The first one is WAI ARIA, which defines ARIA, and it doesn't say anything about how it maps onto the platform APIs, but it sort of defines the basic concepts of what that kind of API looks like with roles and attributes and states and those sort of things. And then other specs will map that onto platform APIs. So if you look at core AAM, which is the core accessibility API mappings, that spec actually tells you, well, on this platform, this sort of ARIA node maps onto this sort of platform node. And then if you look further, you see that there's other specs such as HTML AAM, which is the HTML accessibility API mappings. And that sits sort of on top of both of those specifications. And what it does is it says, okay, here's an HTML element, and implicitly it maps to this ARIA role. And right beside it, it says it also maps to this platform accessibility tree role. So it sort of tells the whole story by referring to both of those specs.
So it really helps sort of stitch them together in these layers. Yeah, there's a lot of accessibility specs. There's also the ARIA authoring practices, which is great if you are a developer, because ARIA also contains like patterns for controls that have no current parallel in HTML, like tab sets and accordions. And
yeah, that's
like
right. Where the HTML AAM provides implicit mappings for already existing HTML elements. If you want to create your own more complicated pieces on your page, then the ARIA authoring guide is a great way to see how some of those should be represented in ARIA.
So the browser is just another one of these apps, and it has to build and map its accessibility tree, and that's complicated. You have ARIA and the mappings to the operating system level thing, but then to create that, you can't even just look at the DOM, right? Like it's more complicated than that, right?
That's right. If you take the example of CSS generated content, for instance, using before to produce content that goes before a particular CSS selector, content selected with a particular CSS selector, that content isn't in the DOM, but it is useful for it to be exposed in the accessibility tree. So essentially, the accessibility tree needs to be built based on the combination of the DOM with the CSS.
Display none, right? Like if it's display none, we can't have it be in the tree, or else that would be bad. And a number of things are implemented like effectively that way, right? Like they're just hidden from display. So you wouldn't want your document to read the head of your, right? Like you don't want reading the text of script elements.
No, yeah. Right.
All right. So we work on all kinds of stuff in this space in more than one browser, right?
Well, looking at the specifications, we're involved in many of the specifications in the editing process. We're also involved in the implementation, focusing mainly on the Linux desktop, but also with other desktops as well. A lot of our work is focused, though, on Linux desktop, implementing the accessibility support for ATK and ATSVI2. We were working in the three major browsers, Chromium, Gecko / Firefox, and WebKit.
When it comes to accessibility on Linux, it would be safe to say that Igalia is a strong ally.
Yeah, I think that's safe to say.
Kind of looping back, like as I said in the very beginning, it's very hard for a lot of us to like even relate to how things should work. Like I'm not the first person to say that if you like just give like a developer who has never experienced a screen reader before, and ask them like, your site isn't accessible, here's a screen reader, go fix it. Like a lot of their intuitions turn out to be wrong, making it worse instead of better. Even if you really know what you're doing, ARIA can be pretty complicated, right? That's why I think the first rule of ARIA is don't use ARIA. Can you maybe talk about that a little bit or something?
Yeah, so I guess I can point to an example of how this is tricky to get right. We've run into issues where people have tried to create something as simple as a button, and they perhaps create an element, an HTML element, and give it the button role, but then they don't allow it to respond to not responding to keyboard events. So say that you create a button where if the user is able to mouse over that button and click it, it works just fine, but it's not focusable, so it's impossible to actually activate it with the keyboard. Screen readers, at least Orca, is smart enough to notice when that's happening, and it will try to click on it, but only if everything is set up properly on the client in the client code. So once you start going down these paths, it's really easy to get into a situation where the screen reader is just not going to know how to operate on your custom element. And that's the kind of trouble you can get into when you start using using ARIA without setting up the elements in a proper way. The thing is, nowadays, screen readers are very similar to web browsers in that they're built to deal with bad authoring, and they have a lot of workarounds to make that happen. To some extent, that's sort of the life that you take on when you work on a screen reader. You have to deal with the web that exists, not the one that you really want to. So I think from our perspective as implementers, things like that, it's just that if there's something that you have to work around, you have to work around it, because at the end of the day, the software has to work.
If the first rule of ARIA is don't use ARIA, and it can be complicated, like who should use ARIA? The way I've looked at this in the past is that ARIA is low-level things, and they're not for the average author. The goal of the platform is to make it so you don't have to use that. And ARIA is then like an escape hatch for when the platform isn't meeting your needs.
I think that's a good way of describing it.
So like in some ways, in theory anyway, it's really good because different people can sort of centralize their work, and they can make like a suite of components that can have all these accessibility characteristics, and that's great. But we also don't have native equivalents of some of those, and the ones that we have, as we say, like people have to turn away from them too quickly. So part of me is wondering if you have any thoughts on like, how did it get that way? Like, how did we wind up here?
There are these sort of two worlds: the web platform implementers and then web developers. And it's really surprisingly rare that there's a big overlap between those two. So a lot of times it's really difficult to know exactly what web developers need or what they're missing, which is why I think this communication between these two groups is really important.
That's a really hard thing to resolve. And I bring it up because I wanted to mention some new efforts at this and get your thoughts on them. So I don't know if you're aware, but Nicole Sullivan at Google and Greg Whitworth at Microsoft are sort of spearheading some efforts to
study why people don't use those elements, and we know plenty of reasons already, but and how to fix that, so to make form controls more stylable and things like that, so that people don't find an excuse to go pop the escape hatches right away. So I don't know. Have you seen that? What do you think about it?
I haven't, but I mean, that sounds great. I feel like that would go a long way toward relieving some of these situations that pop up.
Yeah, there's lots of things in the platform where you currently have to turn to escape hatches, and also those escape hatches are like pretty comparatively low level. There's even sort of intermediate things that we can do to greatly improve like the complexity of a whole bunch of use cases, and make it easier to get things right that aren't even just components, things that make components possible and easier to develop.
Yeah, at the end of the day, if it requires a huge development team of experts to get accessibility right in order to build a web application, then we as providers of the web platform need to do a better job of making it really easy to get accessibility right. Even when you're building these custom widgets, if they're actually required for building modern web applications.
Yeah.
So I think you're totally right that the responsibility for making this work really lies with us and not with millions of web developers who don't have years of experience
I
doing accessibility.
I really really like the the sort of nuance in what you're saying. That a lot of times, like historically, these communities are sort of like at odds with one another, um, like the design community and the accessibility community. And our friend Alice Boxhall, who works at Google, she is on the W3C tag now, and in her candidate statement, it stuck with me. She said, like developers, you know, they want their things to be accessible. It's not that they don't want them to be accessible, right?
Mm-hmm.
It's just currently very hard. And if we make
Right.
it hard to do the right thing, very few people will do the right thing. So we have to find ways to lower the barrier.
Yeah. No,
Yeah.
totally agree.
But have you had any thoughts around like, or do you have any thoughts on like what element should HTML have that it just doesn't have, and that makes it really difficult for a lot of author.
I mean, I think from the perspective of accessibility, the most important thing is that when we add things, there has to be, from the beginning, a story around how they interact with accessibility technologies. And the days of creating controls without actually taking into consideration screen readers and people using them, that just has to be in the past because the web is too big and too important to leave people behind. So I think that large or corporations proposing things, they really need to make their proposals with those
Yeah, I
considerations.
think getting people to agree on any of these things is like really really hard, and historically this has been like really based on a lot of talk and debate, and then at the end of a really long process we give people something, and the question is, did we get it right? Okay, so thanks for taking the time and talking with me, Martin. I appreciate it. I learned a lot in this actually, and I found it sort of informative and useful. So, thanks, thanks.
Thanks. Yeah, my pleasure. Hmm. Bye.